Hello, my name is Clark Whitty, Director of Technology for APT, Spirent Communications Automation Division. And today we'll talk about Python and iTest's most recent integration into Python known as Python SLC. Python is a very powerful scripting technology, and this integration known as Python SLC allows iTest to harness the power of Python, but most importantly, allows Python to harness the power of iTest. iTest's strategy is to embrace Python, to cooperate, and to complement Python. It should not be a mutually exclusive decision to either automate in Python or iTest. It should be that we can use Python to do what Python is great for, and use iTest to do what iTest is great for. The traditional approach to creating test automation is to pair engineers together. One engineer who knows everything there is to know about the devices that they're testing, and the other engineer who knows everything there is to know about scripting. And this is not a terribly efficient way to get test automation created. What if there were a way that the tester himself could follow his natural workflow and create test cases, and then hand those test cases over to the automation team in native Python format? Python SLC allows valuable quick calls and response maps to be consumable in Python, especially important for regression test systems who run tests in pure Python syntax. In this way, test teams who are creating quick calls and response maps can continue to build and develop their test cases in iTest and expose that power to Python consumers. Introducing Python SLC, a way to turbocharge your Python automation. Python SLC is easily installed using the pip package management system. Pretty simple, right? The Spirent SLC library is a client to an iTest instance, and that instance can be a GUI or a headless instance of iTest. The Python SLC client talks to the agent mechanism within iTest. Now, traditionally, the agent has been the agent to Velocity, which is a client to Velocity. And when it's registered to Velocity, Velocity dispatches test cases to run on that agent. Now the agent is being used in server mode, where it sets up a listener port, waiting for incoming Python SLC connections. Let's start by opening a connection to a device in our topology. We're going to connect to a Cisco Nexus router. We connect to this Cisco router and start invoking quick calls that are associated with the device. First, we'll run a quick call called show OSPF interfaces, and then we'll invoke a quick call called verify OSPF on a specific interface on that Cisco router. Now let's run a couple of static commands into the terminal, setting the terminal length and showing the version of the Cisco router. As you can see, iTest has captured all of our activities, the quick calls that we invoked as well as the static commands that we put into the terminal. When we right-click on our captured steps, we can convert those steps into an iTest test case as before, but now with Python SLC, we can actually export to a Python script, or we can copy that script into the clipboard to paste into our favorite IDE. Let's export our captured steps to a Python script, provide a name, and examine the script that was rendered. And here's our Python script, all the quick calls and commands that we typed in during our session. We can use any Python IDE or even the terminal to open up Python and start executing Python SLC code. I'm using PyCharm in my example here. There are a couple of responses that are important to me. I want to capture the output of verify OSPF quick call, and I also want to capture the output of show version. Now let's insert a breakpoint in my script and run the debugger, allowing the script to run up to that breakpoint and stop. Python SLC has connected to our iTest GUI instance, allowing us to see interactively all the commands sent and responses received from the device that we're testing. Now, while we're paused, let's drop into the console and see what we have. SLC list gives us a listing of all the projects we have in our workspace. We have an open connection to our Nexus router. If we use the list method on the connection, we can see all the quick calls associated with that router. If we want to understand what arguments each quick call takes, just pass that quick call in to the list method. Here we can see that the verify OSPF quick call takes one argument, OSPF interfaces, and the description of that argument. I don't have to go digging into iTest to understand how to use this particular quick call. Now let's step the debugger so that we can invoke the verify OSPF quick call. Now remember, we captured the output of verify OSPF into a response object called R1. The output of the verify OSPF quick call is a JSON response. Now let's say we want to identify how many OSPF neighbors we see on this given interface. Because the return is in JSON, all we really have to do is to walk down the structured data tree using key values of the JSON structure. Now let's step the debugger again to invoke the show version command, which, as you can see on the right, returns very unstructured responses. All queries, both auto-generated queries and explicitly defined queries through response maps, are available in the Python session. Here, the version of the Nexus router is stored in a query called kickstart. Now, let's say that I want to verify that the Cisco Nexus is running a certain version of code. We'll build the command interactively. To get the value of any query, just type it into the terminal. Now we'll use Python's assert command to verify that the extracted value coming out of the kickstart query is equal to some predefined string. Now we just drag our assert command into the editor, and we've added validation into our script. Python SLC, turbocharging your Python automation.